Hello and welcome to another developer toolkit. So this time around, what we're taking a look at is being able to make interactive screens in the world. But interactive screens where we have a lot more control over the visuals, because we already know that we can do things where we can set up some worldspace UI, we can fit that to an area, and you can then just interact with it as normal. Everything just works. What we want to be able to do, though, is take that a step further, because when we've just got the UI there, that UI isn't picking up any lighting from in the world. We can't easily go and do extra effects on it, so potentially being able to put on things like post-processing, being able to apply different material effects, stuff like that, or even having it be that it's emitting lights, areas like of that. We don't get that with regular worldspace UI with how we've set it up. We're going to have a look at how we can actually make it work. So let's dive in and see what we've got set up wise to begin with. So if we take a look at the scene, in the actual game view, all we've got visible is this quad here, and separate, a bit away from it, I have some UI here that has a bunch of different screens that it can show. And we want to rig that up so that we're capturing that UI and we're showing that on that screen. That's easy enough. We know we can use render textures to do that. But the step that we want to do beyond that is being able to have it that we can then click on that. Because that's one of the things we do lose. So if I just bring my world space UI back over to here. So I'm just going to bring this back here so that it's in, and I will turn the screen there off. So you can see this in the game view. So regular world space UI, I know that when it's running, I can just click on things and it just behaves exactly the way any other UI works. But I'm going to set this up so that we're going through render to texture. So here's how we set that up. So I've already taken the liberty of moving this so that every component of this is in a separate layer. What I'm now going to do is firstly give it an empty parent object. So I like to keep these all nicely sort of grouped. So terminal UI stage, and you can have multiple of these. I've done having multiple of these in a particular project. That's completely fine. So we've got our UI there, and what we do is we create a camera, and this is going to be my UI camera. Clear flags. We want it to clear to solid color. Typically, if we're working with something like a screen, solid black would be what we would be using. And we also want to bring that camera back so that it's able to be looking at the screen. And now, at the moment we can position it like this. We actually want to turn the projection to orthographic. We don't want perspective on this. So we've got our camera there. Also means that the positioning is less sensitive. We get rid of the audio listener. We don't want audio on that. Culling mask. Well, we want to initially click on nothing and then just screen one, just so we're filtering out what we're actually seeing. And then we can set up our texture. So we can set up so that we have render texture. So our render texture down here, green RP. Now size, I intentionally with this UI, if we take a look, I've set it to be 800 by 600, and I want to actually match that with my render texture. So 800 by 600, and then I can link that up to the camera. That then changes the aspect ratio there for the camera. And then with that, I can actually get the sizing adjusted for this so that it's actually fitting the entire UI in. And if I want to just double check that it's got everything on my screen panel here, I've currently got that set to be clearing to black. So if I change my UI camera so that the background color is something that is unmistakable, so let's go for really strong magenta, unmistakable of the definitely accepted color that means something is usually wrong. Is generally the meaning when we see that, and we can see as soon as we go over 3, we're starting to see the magenta coming in. We can also then check. We went to 4, obviously we're seeing a huge amount. So 3 is looking pretty good there. So we can be capturing that UI, and then my screen here, I'm going to switch back to game view for this. Well, screen, if I hook up the render texture to that material, then my screen, I will be able to be seeing the content on this. So if we have it running, then let's take a look at our scene view. So we're currently not seeing anything appearing on this. So we want to go and check our render texture. So our render texture is looking good. It's capturing everything. But if we take a look at what we did with the material, we were applying a tint to it. So we can get rid of that. But this is the advantage that we have with this of now I've got this screen here. I could be applying a bit of transparency to it. So I could say, yeah, no, this has got transparency, and I could be adjusting that. Gives us a really good level of control over how this is appearing, which means things like lighting will actually affect this material. So we can see at the moment, if I turn off specular highlights, so we get that effect. We could make a screen that looks glossy versus a screen that's more a matte finish. So it gives us a lot of control over there with it. But what we'll see, the downside we have with this is I don't get clicks. Because of course I don't, because my UI is way over to the other side. So this is the big focus of what I want to look at with this, is how do we actually make our input go over to the other object. So there's a couple of pieces that we need for this. And again, I'm going to follow the approach I use with a lot of ones. I'm going to set this up as a standalone sort of system. So I'm going to call this input relay, I think is a good term for it. So we want our screen, which is going to be getting the input. So we've got our relay. So the screen receives it, as in the quad that we have in front of us receives the input, and then it needs to relay that on to something else. So I'm going to call this input source, input relay source, just so there's less of a chance of it potentially colliding with other names. So this is going to sit on our actual screen itself. And its job is going to be to pass through that information in terms of where the user's clicked. So let's see what we can actually do in terms of with this. So, okay, I need to be detecting where the mouse is. That's easy enough to do. I can get that from the input. I then need to work out where that corresponds to on this quad. So let's start off with the simplest approach of where I'm doing a raycast there. So what I would be doing is if I go camera, and I need my main camera. So with my main, so I've got my main camera, and what we'll notice is we have screen point to ray. That's going to be the ideal one that we want to use. Because with that, we can just give it our input mouse position. And that will give us back a ray. And that's just going to correspond to, that ray will correspond to wherever the mouse is in the world. It's using our current camera. So that's good, because that allows us to then set up so we can do a Raycast. Now for something like this, I would also do the usual thing of setting up a layer mask for this so that we're only doing a Raycast against the things we need to potentially. We do want to factor in, we don't want to hit it if there's level geometry in front of us, but it would allow us to filter out some of the things we're raycasting against. Raycast mask, and we'll just default that to everything. So, F, physics, Raycast. So we want one of the variants where we give it a ray. So mouse ray. Well, we know we need to have a distance, so we're going to assume we'll have a variable set up for that. And we know in terms of output that we'll have ones here where we can grab the output. So those have the hit result here, have our distance. We can provide our layer mask, Raycast mask, and we don't want to hit triggers for this. So that looks pretty good. Serialized field, our layer mask, so float, Raycast distance. Now in this case, because the camera is fixed, I'm going to use a fairly large distance. If I was using this on something like a first-person controller, I'd be using a very small distance. So this is intentionally quite a large distance, far larger than we would actually use. Similarly, if we were doing a first-person one where the mouse is locked, we could grab the screen's width and height and use that to work out the center location. So Raycast to find what we have hit. So if we have hit something, it's a particular thing I'm interested in with this. So well, first thing, I want to check if what we have hit is actually us. If hit result dot collider dot game object is equal to that, I'll check actually if it's not. So if it's not, we exit. Ignore if not us. Then what I want to do is I want to check and see where we hit on this. So debug log hit result, and what I'm interested in with the hit result is, so you have these other ones here in terms of things like texture coordinates and so forth. So let's log out the texture coordinate, because that's potentially going to be something that will provide us the information we need. So we'll have our screen going. Screen's going, good, Raycast mask. We can get rid of a couple of ones here. We really only actually want to be raycasting against default. So what I'm looking for is seeing, I'm hoping to see that when the mouse moves over this, I start to see some output. And I do. So down here is 0. You can see it's varying. If I go all the way over to the right, that's gone. The X has changed to 1. And so that looks pretty good. It's managing to give us back useful input. What if this screen is rotated though? Let's just check and see if this works when we are behind it. Behind it, and that's good. We're not getting output there. What if it's on like a sharp angle to us, like of that? Does that still work okay? And the answer is yes. That's good. We've got a 0 to 1 range. And the advantage with that is if I also, just for interest, debug log out my input mouse position. So we'll take a look at this. And I just want to see how this varies, just to get a sense of is 0, 0 was the lowest value down the bottom left, which it is. And highest value is top right. Perfect. So that means I have a value that is changing over the range of it when we're looking at it, and I can then relay that onto something else. So what I'm going to essentially do is inject this input into the other UI. So this is a good case of where I would use events for wiring stuff up. The Unity engine events, and I'm going to create a Unity event that has a vector, and I will keep it as a vector 3. Actually, no, it'll be a vector 2 for the texture coordinate. It's vector 2, and this is going to be the thing that will receive the input. So on cursor input. Now, if you're using an older version of Unity, you wouldn't be able to necessarily do this syntax. You might need to have public class and create something that inherits off of Unity event first and mark that as system.serializable. With the newer versions of Unity, we can directly do this, and these will serialize completely fine, which is great. Because then what we do here is we just go on cursor, input, invoke, and then we pass get result dot texture coordinate. Done. So that's the receiving the value side of things. Now we need to be able to inject this data into our terminal UI. So I'm going to add the script onto this. So this is going to be input relay. I'm going to call it sync. So sources and syncs. So this is going to sit on the same level as the canvas. So this, one of the chief things it's going to have is public void on, and what did we call it? We called it cursor input. So on cursor input, vector 2, normalized position, because that is what we're getting. It is a normalized position. So, okay, it's getting a normalized position. We need to look at how we can inject that into the UI. So because this is the thing that we can do, we can inject input that we receive into the UI. Now, when UI gets input, the range that it gets that in is based off of the dimensions of the canvas. So one of the things we're going to need here is we're going to need to know the size of the canvas. So this is where we can go rect transform canvas transform. And so we want to convert our positions into normalized ones. So let's take a look and see what we've got. So canvas transform. And if we take a look, we've got this size delta. So let's see how that looks. So vector 3, this is going to be the mouse position. That's going to be a new vector 3. Our X component, let's try that. Now Y component is going to follow the similar process, size delta.y. This one uses size delta.x, multiplied by, again, our normalized position.y, within the final coordinate being a 0. So let's hook up this and make sure that we've got values coming through that look correct. because we know our UI, we set this up to be 800 by 600, which means with it being 800 by 600, we would expect to see bottom left be 0, 0, whereas then top right should be around that 800 by 600. So we'll link up our rect transform, and we need to have our cursor input going to this. So we have our input relay sync and our on cursor input. So let's test this out and see what we're getting in terms of values there. This will tell us if it's communicating, and then hopefully also show that we're getting valid locations. So we've got quite low positions there, which makes sense. We should see that. Scaling up to about the 800 by 600, which is good. That's what we want to see. So we've got values coming in. So calculate the position in canvas space. So we've got our normalized position has come in. We've got this now in canvas space. So now we can inject this data into it. So this is where we are making use of these some things within the event system. So we need to bring in Unity Engine event systems. Because what we will do is we will actually inject what's called a pointer event data. So construct pointer event. So what we can do is, because we've got different ones that we can actually be sort of feeding in here. So we say pointer event mouse event is a new pointer event data. And so with when we create a new event, pointer event data, we have to give it our event system, which we don't need to have any references here. We can just go event system.current. Will give us the current active one. And then that mouse event, we can set our position, which is our mouse position. Now something we'll notice is the way it works on UI is it gets that info, and then if we take a look at our UI, has this Raycaster on it. That's what actually works out what's being hit. So we can use that Raycaster. So we would set up here, and if we don't need that to be serialized field, what we can do is we can have our Raycaster, which, so for that, we need to make sure we've got our Unity Engine sort of set up in here so that we can access that. Because if we take a look, our Raycaster is within that. So Unity Engine, UI, graphics Raycaster, which I will bring this up to here. So we're using that. So we've got our graphics Raycaster. And I can retrieve that just in start. So Raycaster. Get component, graphic Raycaster. And this behaves much like the physics Raycaster that we're used to, because we can then say, hey, Raycaster. And if we take a look, one of the functions that we have in it is Raycast. And we provide it a pointer event data, which we've created. And we need it to have a set of results that it depends to. So we would set up here, list, Raycaster, and we can see this gives us back a Raycast result. Results, was new, list of that. And so this one doesn't provide us a true or false or anything like that. On the Raycast using the graphics Raycaster. So we'll need to actually check if it has actually interacted with anything. So we need to check what it's actually hit. Because quite likely, in most cases, it may not hit anything or may not hit anything that we necessarily care about. It's only going to be in a sort of narrow range of cases where we actually care about what stuff it might have hit. So what we can do, process the Raycast results. So for each result in results. And let's just initially, so this result is going to give us a game object name. So let's just log that out. It's just going to tell us if it's actually interacting with anything. And that's going to be an important thing. We want to know, first of all, is it actually hitting anything? If it is, then we can proceed on to the next step. But we just want to do this piece by piece testing as we go, because there's a lot of chain of things that could go wrong. So we mouse over, because we see we're not getting anything coming through with that. And that's why we do this bit by bit, to get a sense of why it might be working or why it might not be working. Because this is trying to debug log the stuff out. We know that it's getting input there, but we need to work out why is it actually not picking up on anything. So we know that it should have the Raycaster. We want to just check the settings with the Raycaster. Those look correct. We shouldn't need a camera setup, simply for the fact that we are manually injecting the data, and it specifically says that it might not register results, and that's okay. So okay, we know we're passing through the position, and that position looks like that should be correct, but let's just we already have that logging happening. There's a couple of other things we can sort of check with this, because we're not providing a Z value there. So we could see potentially if we need to do anything like of that. The other things that we can sort of be checking with this is just being really thorough of making sure we have, checked across a range of positions here for being able to display anything, make sure we've got errors turned on. So we're definitely seeing nothing at any point coming through with these. So you can see just nothing coming through there. But let's check and debug log out those mouse positions, just to make sure that those mouse positions look reasonable and make sense, and so that we know that that code's being activated. We're running, so we do see definitely the code's activating. We see the range of positions, which is good. So we know that side of things is working. So we can be confident that we are injecting the data there in terms of we're passing through the positions. We can check and make sure that there's not some, because we are needing to make use of our event system. But our event system looks fine. Nothing there that's a particular concern or that doesn't look correct. So we know that's fine. With our graphics Raycaster, one of the things we could try is, okay, does it make any difference if we have a position here on the Z? So that's the thing we can immediately check. So we check -5 and also 5. So we're checking either side of the canvas. Important just to make sure if that makes any difference. So we can see that's not picking up on anything. We would try then the other side. And with this, we'll do a similar process. We run, and we just want to check to see if it's actually picking up anything. So we're seeing that it's pretty consistently not. Now, we could try, okay, we are doing the scaling here. We could try seeing, okay, maybe there's something going wrong and we actually shouldn't be doing the scaling. So let's try that. Let's get rid of the scaling and we'll just use the normalized position. That's going to consistently be a value that's between 0 and 1. So we'll check that and see if that is giving us anything different. Just because it's good to, with these, we often want to just check a few different things. But no, we can see pretty consistently that is not working. So, and this is again why we do this bit by bit, so we can actually be debugging and working out where the problems are along the way. So the issue that we're running into is we actually do, see I've configured it now, we actually do have to have this with a canvas set to a particular camera. In this case, I rendered a texture one. Even although it's not really needing that and we're manually injecting things, it won't actually successfully perform the raycasts without having that event camera. So we can see now when we mouse over, it knows exactly what stuff I am over, which means we can now start to inject the particular things into this. So I can be checking if we should be sending mouse down. We'll send mouse down. It's going to be input get mouse button down for the primary axis. We'll send mouse up. Also for the primary axis, so get mouse button up. So we've got that information, because that then lets us get here and we can go, okay, well, if we are sending the mouse down, then we can, this is how we actually inject events. We do execute events, and then I can say, I want you to execute, and we can tell it the type of thing we're executing and who it's going to. So the first thing we do is we say, hey, well, this game object, this is the, who's actually going to be executing it. We can give it a pointer event data, and with the pointer event data, we again give it our event system current, and now we can tell it the particular event to execute. So execute events, and we can see we have different ones here. So like in this case, pointer down handler. So if we're sending the mouse down, then we can do that. We can do a similar thing for sending, and we'll make sure that's on the next line properly. So we can do the exact same thing, but then when we are wanting to send the mouse up event. So we've got mouse down being sent, we'll send mouse up, again, execute events, pointer up handler. That's good. We could also generally feed in that mouse event, so we've got position information there. So we can do that. So we don't need to actually create a new one. So, okay, we can send mouse down, we can send mouse up. See if it works. What we should be able to do then is click on the buttons here, and that will activate those ones on the UI. So let's find out. We're running, can click, so we can see those are highlighting, which is good. So we've got them actually activating. There's a level of activation there. Now, if we take a look and see execute events, we also, because our handler is on click. So generally what we would be doing is when the mouse comes up, that's when we would also execute a click event. So the mouse has gone up, and we can go click. So we'll run this. And we'll just make sure we want to see we can go and activate the particular ones. So now these are reacting, which is good. What about dragging? We can certainly click on locations, but it's not really giving us more than that. So that's stuff where we could be relaying through other events here. Okay, so we want to get dragging up and running, but dragging is actually quite a complex operation. because there's a lot of things that need to be provided for dragging to work. And if we take a look at the stuff the scroll bar is doing, the scroll bar is making use in terms of our pointer event data. It's making use of information there like position, stuff like that, which we'd expect. But we can also see it's looking at things like it wants those results from doing the raycasting. So there's a lot of extra information that we need to be providing here for this. So what I'm going to do is I'm going to set up a new pointer event data here, and each one that runs, so each one that I execute this logic on, is going to get that new pointer event data. So this is going to have position, needs to come across, so we have our mouse position. We need to pass in the result, which we can see if we go for pointer. We have current raycast and press raycast, so we want to set both of those. So the pointer press raycast, those get set to our result. So set up the new event data. And the other bit of information that we can be feeding through there is event data dot, and we'll be able to see the button, because if we look in the scroll bar in particular, and a lot of the other UI ones follow this same convention, when they are looking to see if they can actually perform a particular thing, they will go and check the particular button. So we can see it's checking if the input button left has been received, because that's how it interprets. It's not actually going to always be the left button. In this case, it means primary. So what we would be doing is if our input, and we'll actually have here is mouse down, mouse button. So we've got that distinction between it's down this frame versus it's continually being held down. So this is going to give us a better setup for our event data. It gives us one that's a little bit more detailed in terms of the information that's passing through. And if we run that, we're not going to be able to do scrolling yet, because we're not going to be able to do dragging yet, because we're not providing the drag events for it. So we can see now if we click, it's properly moving to the right location, which is good, but we can't drag. That's not something that it's supporting yet. So drag has 3 stages: begin, update, and end of drag. And we need to pass that drag information through to all of the possible recipients. So what I'm actually going to need to do here is be tracking the locations there, or the things receiving dragging. So drag targets, new list of game objects, because I could have multiple things that need to receive this drag event. So what we need to do then is, okay, well, first thing is we're going to check, is the mouse gone down? This is where we potentially can populate drag targets. So in this case, if the mouse has gone down, we might be updating ones, but also in particular, if the mouse has gone up, then all of those drag targets are going to go away. But before we get rid of them, target in drag targets. So before we do that, we are going to send each of these result.game, so to target, we are going to send our mouse event and end drag. End drag typically doesn't look for too much. So on BeginDrag, we can see there's a lot of stuff that it's checking. Same with on drag. the ending of drag won't always at times be implemented. So we can see we've got begin drag, and on updating it, but often the actual ending is not really doing anything. But we'll make sure we send it through anyway. Send through end drag events as needed. So we only need to send through that when the mouse has gone up. Now, if the mouse has gone down, then we might need to, this frame, update that list of drag targets. Here's the mouse down. So what we would be checking here, if we have sent mouse down, then I'm going to populate the list of drag targets. Drag targets, add, and what we would add in there is result.gameObject. So we've just added that in. Now we could send that BeginDrag event. So we execute result.gameObject, event data, BeginDrag handler. And if we look at the beginning of dragging, then it's using those Raycast bits of information we've provided through. So that looks good. So we can update that. So potentially new drag targets. Otherwise, what we would do is we would update this. So rather than it being beginning of the drag, we send through just the actual drag handler one. The drag handler. Now, we could be doing some filtering here where what we do is we also then check if drag targets contains result.gameObject. Need to update drag target, because what we could do is do a bit of extra filtering if need be, looking for things that actually make sense for them to be drag targets or not, or just checking to see has there actually been any movement there. But we've got that information being pulled out. So let's see. We're adding stuff in. We're sending through that execution. We've got extra information here. We would also, in this case, if we are updating one, then we can say dragging is true. So we just put more information into that pointer event data so that the assumptions that the rest of the UI is trying to make, it can actually safely make those. So let's test that now, see if we're able to drag that scroll view around. So we're up and running. We can switch over, so we can click, and we can see. So in this case, it's able to be sending the drag event to multiple particular things. So that's because if we look at our results, and I'll actually wait till we get a set of results here, because these results, it's going to be able to give us back multiple things. And we can see in results, now in this case we've only got one, so we're going to let it run down to here. And we'll actually wait till we are sending a mouse down event, because that's something where we can control. So here, if I click on this, and then in results, we've got multiple things. We've got the actual button, we've got the containing panel for it, the containing panel for that. So we can actually see, so distance for this one is 4.699, distance for this is the same, distance for this is the same, but the depth is different. So these are sorted by the particular depth that they're in. So as we go deeper, different things are actually going to be getting picked up by it or not. So that's something where we could potentially be controlling which ones we actually send all of that input to. Because we could see that it was correctly scrolling, but what was happening was we were able to be sort of zooming around a lot more with it than we otherwise would necessarily want to be able to. So in terms of with that, there's a couple of things we could, be experimenting with there to try and sort of adjust and control that behavior there. So if we ran it up, because we want to take a look closely at the behavior we're seeing. So because we can see as we scroll, it does correctly scroll, but what's happening is the scrolling is actually happening within the scroll view, not just the scroll bar. So that's something where we want to be able to filter that out a little bit so that we're not having this data go through too many things that it doesn't actually make sense with. Now, if we just turn this so it only processes the first layer, that's actually not going to work nicely. It's actually not going to give us the behavior that we want, because if we run this, what we will see is doesn't actually move at all, because the thing that we're clicking on is the handle, and so it needs to go through a little bit. So we've got some stuff where it needs to go through 1 to 2 layers, other ones where it potentially needs to go through more. So we've got a few different options of what we could do here with this. So we're going to have a look at some ways of how we can make this work a little bit better. So for this, we've actually got a really effective way of how we can handle this, because our setup here, this execute function, actually tells us if it did anything. And what we can do then is any of these ones where it actually does something. So if we have executed it, then we break. So that means we can also, down here, where we are adding things in, if this was successful, then we add that into the drag targets. So that means we're executing it on less things. Our drag targets has less stuff getting populated into it. This one's fine because we're already filtering based upon what ones the information is able to be going into. We can do similar here, where if we group these, then, okay, well, if we have successfully executed that, then we don't actually send any more. And then similar with these I would probably be inclined to group. We could call this something like did run. And so we can check if it ran, and we'll get rid of that being called result. So if it ran, then we exit, because something's actually processed this data. Now we could be a little bit more nuanced in terms of, okay, well, we do a pass that is only the down events. We do a pass that is only the up events. But let's see how this goes. Does this give us better behavior there? So we're up and running. So we can still click on our buttons, which is good. And we'll notice we can scroll, and it's not scrolling the whole panel. And we can scroll separately here, as it could before, but only by clicking on these things. So we've got our UI running. It's running with the material which means, as we saw before, we can modify this. We can change how reflective and shiny it is by changing things like the smoothness. Can change the metallic setting for it. Lots of different things we could configure here. We could be applying another texture over the top of this. We can be tinting it. We can be having the lighting in the scene is affecting this. So it makes it more integrated into the world, but integrated into the world in a way where we also have our user input working with it. So it means that we get the benefit and the advantage of having those worldspace UIs that look really cool, that can be really ingrained in the world, but we're able to then also still have user input working with it, which is incredibly handy. Allows us to make our projects work a lot better and a lot cooler. So dive on in with this and experiment with it. If you're looking for the code for the project, as always, the full code is up there on GitHub with the link in the description below. You can use that code for any of your own projects, whether they're commercial or non-commercial. So dive right on in and use it. I've set this up so it's nice and modular, so you can easily bring it into your own projects there. If you found the video helpful, please do chuck in a like and subscribe. It really does help out. If you're looking for other ways to help out, then I do have a Patreon and the link is in the description below. But dive on in, make some cool stuff. Bye.